Let's look at some homework problems from chapter 6.2, and these are all going to be differential equation word problems. Okay, let's start with 21. Rate of change of y is proportional to y. When x equals 0, y equals 4. When x equals 3, y is 10. Find the value of y when x equals 6. So first, we need to be able to read the sentence and be able to create our differential equation. So rate of change of y, so this is talking about y prime. So y prime is equal to, when we see the word is, we can say equal to, proportional to y. So this is going to be in the form of y is equal to kx, proportional to y, so k times y. So that's our differential equation. Y prime is equal to k times y. This is with respect to x, so we're going to rewrite y prime as dy over dx and separate the variables. Dy over y is equal to k dx. And we can also list out the ordered pairs before we go any further. So we know the ordered pair 0, 4, we know the ordered pair 3, 10, and we're looking for y when x is equal to 6. Okay? And these two pieces of known ordered pairs will help us solve for c and solve for k. And once we have our specific solution, then we can plug in 6 into our specific solution to find our y value. So continuing with solving the differential equation, we can take the integral of both sides. The left side is simply just going to be the natural log of u, so natural log of the absolute value of y is equal to constant. So integral of a constant is constant times a variable plus c. We want to get the y out from underneath the natural log expression, so we're going to exponentiate both sides. E to the natural log of y will just simply reduce to be y. E to the kx plus c, we can rewrite it as e to the kx times e to the c. E to the c is just a constant. We can pull that constant out in front. So now we have our general solution, and we can start plugging in these ordered pairs to help us solve for c and then k one at a time. So to solve for c first, plug 0 in for x, plug 4 in for y. E to the k times 0 is simply just e to the 0, which is 1. So c is equal to 4. So we have our solution. For the most part, we're just missing the k value. So replace 3 in for x, replace 10 in for y. We have the second order pair now that we're going to plug in to solve for k. And so we're going to, step at a time, try to solve for k, but we need to move some of these terms away from it. So divide by 4. So 10 over 4 is equal to e to the 3k. 10 over 4 reduces to be 2.5, so 2.5 equals e to the 3k. We want to find a way to solve for k, but k is sitting up as an exponent, so we're going to take the natural log of both sides to allow this exponent to come down using the power property for logs. So take the natural log of both sides. We get natural log of 2.5 is equal to natural log of e to the 3k. Bring the 3k down, and the natural log of e will just go away. It's equal to 1. And so we get 3k is equal to natural log of 2.5. Divide both sides by k, so we have k is equal to natural log of 2.5 divided by 3. We have the k value, we have the c value. Now we can write our specific equation. Y is equal to 4e to the natural log of 2.5 over 3 times x. We have our specific solution. Now we can find our missing y value. So plug 6 in for x to solve for y. So 4 times e to the natural log of 2.5 divided by 3 times 6. All this can go in your calculator, and you're going to reduce to be y is equal to 25. All right, 23. Rate of change of v is proportional to v. When t is equal to 0, v is 20,000. When t is equal to 4, v is 12,500. Find the value of v when t is equal to 6. So our independent variable is time. Dependent is v. So we know a couple of order pairs already. We know 0, 20,000. We know 4, 12,500. And then we also know that we're looking for the v value when time is equal to 6. Okay. All right, now let's write our differential equation based off of the sentence. Rate of change of v, we see the word rate of change describing v, so we know this is talking about v prime. V prime is equal to, you see the word is, equal to, proportional to v. So this is in the form of y equals kx, so k times v. So v prime is equal to k times v. Take the steps, rewrite v prime as dv over dt, separate the variables. dv over v is equal to k times dt. Take the natural log of the left side to solve. Integral of dv over v is in the form of 1 over u, so that's simply going to be natural log of the absolute value of v. The right side is kt plus c. Split this up. We can exponentiate both sides first, and the left side becomes v. The right side is e to the kt times e to the c. Pull the c in front. Now we can start finding our missing variables one at a time. 20,000 goes in for v, 0 goes in for t, so we get a k times 0, which is going to be 0. And then when we solve for, and then e to the 0 is simply 1, so c is simply equal to 20,000. So v is equal to 20,000 e to the kt. Now we can solve for k, so let's look at another order pair that we can use to help us solve for the missing variable. Okay, 12,500 replaces v. 4 replaces time, or t. So we get 12,500 is equal to 20,000 e to the 4k. Divide both sides by 20,000, we get 0.625 is equal to e to the 4k. We want to solve for k. We want to bring this down from an exponent form. So take the natural log of both sides. Then this 4k can be brought down in front, and natural log of v disappears. Last step, divide both sides by 4, and we have our k value. Okay, we have our k value, we have our c value. Now we can write our specific equation, and we can plug 6 in for t, and then solve for v. So all this goes in your calculator, and this reduces to be 9,882.118. Okay, let's see if we can get through one more problem here, number 35. Radium has a half-life of 1,599 years. Given that after 10,000 years, only 0.5 gram remain, find the initial quantity and the amount after 1,000 years. So the initial amount, we know, is at year 0, there's an initial amount of C. Okay, we don't know what that initial amount is, so I'm going to just use C to hold that information. After 1,599 years, only 1/2 of the initial amount will remain, so we'll represent that with 1/2 times C. Okay, we're going to use the form that we've been seeing from before, y is equal to CE to the KT. Okay, we have a couple of ordered pairs that we can use to solve for K. So replace y with 1/2 C, replace T with 1,599, and the C's will cancel out. We're left with 1/2 is equal to e to the 1599k. We want to bring this k down from the exponent form, so take the natural log of both sides and bring the 1599k in front, divide both sides by 1599, so we have our k value. Once we have our k value, then we can write our solution. So this is a little bit different because now in this case we're actually solving for k first before we solve for c. And the reason why we do that is because we don't have a value for c in order to plug in and find the initial amount. So we have to work backwards a little bit. Okay, so y is equal to ce to the, this represents k times t. And we know that there's 0.5 gram remains after 10,000 years. So replace 0.5 in for y, 10,000 in for t, and we can just work this out. Divide, this reduces to be 0.13103. Divide both sides by that value. We have our c value being 38.158. So this is a little bit backwards, but we found the c value, we have the k value, we have our specific solution. Okay, and then finally, it says find the amount after 1,000 years. So we can plug 1,000 in for t and solve for y. So replace t with 1,000, plug all this into the calculator, including 30 times 38.158, and we get y is equal to 24.736 grams.